In this video, we are going to understand the concept of types of functions. In class 12, we are going to study about two types of function. One is one, also known as injective. The second one is onto functions, also known as surjective function. Now, before we understand these two types of function, we should have the idea about domain, codomain, and the range. Now, let's to understand this, you can see I have taken some arrow diagram, 1, 2, 3, 4. Now, first is domain. So let's understand what is domain. So by domain, we have already understood that it is always the input. So whatever is the input for the function is called the domain. So if you look into the arrow diagram, we can say for the first function, it is the domain is 1, 2, 3, 4. For the second, it is 1, 2, 3, 4 again. And third, 1, 2, 3, 4. And 1, 2, 3, 4. So the domain I have taken all same for all four diagram. Now let's understand the range. Now before that, we should have the idea about the codomain. So the codomain is all the elements present in the second set. So second set is X2 here. So all the elements present in the second set is called codomain. So we can see that for the first arrow diagram for the first part, it is A, B, C, D, E, F. For the second, it's same A, B, C, D, E, F. For the third, it is A, B, C. And for the fourth, it is A, B, C, D. Now, once you know what is domain and range, let's understand what is domain and codomain. Now, we are going to understand what is range. So, range by definition is all those elements of set A which have some relation with set, all those elements present in the second set which have some relation with the set A. So what you can see that here 1 is related with A, 1 is related with A, the image of 2 is B, the image of 3 is D, and the image of 4 is C. So what you can see from here that E and F, element E and F, although it's a part of codomain, is not the image of some element in the domain. So we will say that the range here is only A, B, C, and D. So we can say that if you are asked what is range, we'll say it is A, B, C, D. Well, range for the next part, that is the second, you can see that B is the image of 1 and 2, B is the image, C is even the image, and D is the image. So here you can see that A, this is A, E, and F, although part of a codomain, but we will not call it as a range because it is not the image of some elements in the domain. Similarly, if you look into the third part, we'll say that here the range is A, B, C. Well, codomain is also A, B, C. Right. So we can say that here the range coincide with the codomain. Now coming to the last part, the range is A, B, C, and D as it is the image of some elements of the domain, and codomain is also A, B, C, D. So here also the range is coinciding with the codomain. Now, once we have done this, we can also figure out that like in this case, the range, which is this, is actually a subset of codomain. Look into this. This is the range here, and this is the subset of the codomain. Here the range and codomain coincides, but still it is the subset, and so is the last case. So once you have figured out what is domain, codomain, and range, it will be easier for us to understand what is one function, also known as injective function. So when we look into the first diagram, we can see that Here 1, the image of 1 is A, the image of B is 2, the images of 3 is D, and the image of 4 is C. So what you can see that here this function, the image of distinct element of X under this function, say F1, under this function F1 is distinct. By that, we mean to say that we can say here that each element of this domain has one unique element in the codomain. Or conversely, we can say that no two element in the second set is the image of no two element in the second set is the image of two different element. Now more clarity will come as we do the next part. Let's say in the next part, I can see that B is the image of A1 as well as of the 2. That means B being the image of two different elements in the set X1, that is the domain. So here we will say that it is not 1, 1. As the B is the image of two different elements. So we should say that many to one, like many, more than one should be considered as many, right? So many to one. So we'll say that this is not a 1, 1 function because the element 1 and 2 in the domain have the same image, that is B, in the codomain. Or otherwise we can say that since F1 is equal to A and F2 is also is not A, sorry, is B, right? So I should write it again. F1, which is equal to B, and F2 is also equal to B. So here F1 is equal to F2. Well, X1, well, 1 is not equal to 2, right? So we say that this is not a 1, 1 function, and a function which is not 1, 1, a function which is not 1, 1 by default, it should be called as many 1. Now to figure out whether the third case, is it a 1, 1 function or not? Clearly here also, the element 1 and 2 in the domain has the same image, that is A, in the codomain. So again, it is many to 1. Now, we can also write in the examination why it's not a 1, 1 function by stating that F1 is equal to A and F2 is also equal to A. Well, at the same time, here 1 is not equal to 2. And that's why it is not a 1, 1 function. Coming to the last part, here 1 is related with B, 2 with C, the image of 3 is A, and the image of 4 is D. So we can see that no two elements in the domain have the same image in the codomain. And that's why we say it's a 1 to 1, right? Not many to 1, it's 1 to 1. And that's why we can say that it is a 1, 1 function. Now for the onto, if you see the definition of onto, what does it say? It says a function is said to be onto, also known as surjective, if the function from x to y is said to be onto function or surjective if every element of y is the image of some element of set X. By that it means to say that, in simple word, we can say that if all the elements of set B get exhausted, or if all the second set, where it is X2 in this case, is the image of some element of the domain, then we say it's an onto function. There's other way also you can say when the range is equal to the codomain. When the range and codomain coincides is equal to codomain. So we can figure out, as you can see here, that some of the elements like E and F is not the image of some elements in the domain. As you can see here, the elements A, B, C, and D are the image, but E and F are left over here. So when all the elements of set B is not getting exhausted, we say that it is not a onto function. Instead, if it is not an onto, we say that it is an into function. So we say that if the range is not equal to codomain, as in case of this, the range is this, and the codomain is this. Here the range is not equal to codomain, so it is not a one onto function. Now let's check for the next. Here the range is this, while the codomain is this. Clearly, the element E, the element A, element E, and element F, they are not the part of range, or they are not the image of some elements in the domain. So this is not a onto function. Coming to the next, we can see that the range here is ABC. Why do I say the range is ABC? Range is the output, or you can say that ABC are the image of some element of the set X1. As you can see that here A is the image of 1, A is the image of 2 as well, B is the image of 3, and C is the image of 4. So we can say that here the range coincide with the codomain, or we can say that the range is equal to codomain. So clearly it should be considered as onto. As I said, onto is also known as surjective function. Now let's come to the next, that is the fourth part. What you can see that here the range is A, B, C, and D, right? And if I say codomain, it is also A, B, C, D. As you can see that each elements of the set X4 here, X4, or the second set, is the image of some elements of the domain. That means all the elements of set X2, that is the second set, is getting exhausted. None of the element is left isolated, or it is not being made the part of the image. And that's why we should consider this to be an onto function. And so you should know that the function which is both 1, 1 as well as onto is known as bijective. So bijective, by that we mean to say if a function is both 1, 1 as well as onto, then it's called bijective. Otherwise also we can say a function which is both injective as well as surjective should be called as bijective. So if you look into the bijective, we can see the first one is 1 to 1, but it is not onto, as the elements E, F are not the part of codomain, but not part of range. So it is just 1, 1, but not onto. So it is not bijective. So we can say that this is not a bijective function. For the next, we can say again it is not a bijective function. As you can see here, let me show you here elements. This is many to 1, right? This is many to 1. So it's not an onto into, sorry, by that I mean to say that it is many to 1. That means it is not a 1, 1 function. At the same time, it is not onto because the elements E and F are left over and they are not the part of the image or the range. Coming to the next, that is the third part. This is many to 1, but it is an onto. Still, we should not call it bijective, because for bijective, it has to be both 1, 1 and onto simultaneously. So we say that it is many to 1 and onto, but this is not bijective. For the last part, if you look into this, what you can see that this is 1 to 1 also, and this is 1 to 1, right? Each elements has a distinct image. No two elements in the domain, no two elements in the domain has the same image in the codomain. Moreover, it's very clearly seen in the diagram that each element in the domain, codomain, is the image of some element. And as I said here, that is the codomain and the range coincides. So this is both 1, 1 as well as onto. So we can say that this is a bijective. This is the only one which we can call it as bijective because it is both 1, 1 and onto. Now we'll do more questions based on the types of function.